Okay. So you should have your notebooks out, and I'm going to have you actually, we're going to be opening to a fresh page at the end. So this is where we're doing kind of the in-class review.
Like all the way down?
Just after the last set of notes is fine, as long as it's a clean page. Right. I'm just going to turn this a little bit. Here we go.
Is that after the last set of notes we should?
After the last set of notes, yeah. And what I would like to do is give you guys a chance to ask me to model problems for you that you think you need another example of, all right? So feel free to kind of look through all of the tabs and all the different pages. So if you want me to do like a distributive property problem, or you want me to do a function notation problem, right? So just take a gander through that and see if there's anything you would like me to model for you before I kind of get into my own set of video. Is there anything anyone would like me to specifically review? Liam?
I don't understand perpendicular lines.
Okay, so let's do a review of that. And because we're talking about perpendicular, it'll also be helpful to talk about parallel. So what I'm going to do is I'm going to label each question by unit. So this is in unit 4. And again, it's covering parallel. God bless you. And perpendicular lines.
Wait, do we write this down or no?
Yep, you should write this down. So I'm going to give you a practice equation like this. Y equals 3 halves x plus 6. So you'll be given an equation like that. Actually, take a look at my old file to see what kind of questions I asked about it. And I will be asking you it'll be a multiple choice question, right? But the main thing you need to be able to do in order to identify if it's parallel or perpendicular is be looking at the slope, okay? So over here I'm going to write parallel. So what makes a line parallel to the one given? What do we have to look at? Liam?
Same slope.
For parallel, the lines have to have the same slope. Right? So a line parallel to this one would have the slope being equal to 3 over 2. However, for perpendicular, and I'm just going to go back to our notes for a moment. Everyone's done writing. So again, I'm going to our perpendicular line notes, which is on this green page in Unit 4. And so it says, 2 lines are perpendicular if they meet at a right angle, and they have slopes that are opposite reciprocals, right? These 2 words are super important, opposite reciprocals, right? So opposite meaning, since this slope is positive, this slope has to be what? Negative, because it's an opposite. So I know I need a negative sign. And then reciprocals means what? What do I have to do? Liam? Flip it, right? So if this is the original slope, my new perpendicular slope is going to be negative 2 over 3. And again, that represents m. for a perpendicular equation and for a parallel, does the y-intercept have to be the same, or does it have to be the same? That's my question.
Wait, to be parallel?
To be parallel or perpendicular, does the y-intercept from the original equation have to be the same? No, and in fact it shouldn't be the same. For perpendicular it could, alright, but for parallel it definitely should not be, because that's not a different line or a parallel line, it's the same line. So it's technically just one line, okay? So for either of these, this one has to have a different y-intercept. So if you want to write that, you can. This one can have the same one, but chances are it will be different. And again, on the test, these two questions, one is about parallel, one is about perpendicular. They are multiple choice. Anyone else have a topic or a type of problem they would like me to go over? Morgan?
Can you go over dividing monomials with like the coefficients?
Absolutely.
Thank you.
Alright, so this is in Unit 6. And we are again talking about dividing monomials with coefficients. Let's see. I'll give you one very similar. Just want to go on the final last year. So I'm going to do two examples, one with the bigger coefficient on the top, which I think is easier, and then one with the bigger coefficient on the bottom. So we have example. Let's do 4a to the 4th and b cubed divided by 8a squared b. So here we have a smaller coefficient on top. So that means that when I do these, again, numbers go with numbers, A's go with A's, and B's stay with B's. Alright, so I'm going to deal with the numbers first. I have 4 divided by 8. Alright, so what is 4 divided by 8? Masha?
2.
Not 2, that's 8 divided by 4.
4.
Nope. Ma'am? Nope. 4 out of 8. A half. Yep. So with problems with the smaller number on top, you're going to have to simplify the fraction. Alright? So simplify the fraction.
Is that only with the smaller ones on top?
Correct.
Okay.
If the bigger one is on top, chances are you're going to get a whole number answer. Alright, and I'll give an example of that in a moment. So 4 out of 8 equals 1/2. Now, a to the 4th divided by a to the 2nd. What happens with those exponents again?
You subtract?
You subtract them. So a4 minus a squared, 4 minus 2 is still 2. So I have 1/2 a squared. And how many b's am I going to have left? 2. I have also b squared. You could also write it if you want. Same thing, a squared, b squared, all over 2. Because technically there's an invisible 1 coefficient in front of a that you don't need to write. Okay? So either of these are acceptable answers. And now I'm going to do one where the bigger coefficient is on the top. I think those are a little bit easier. Alright, so here's another example. Let's do 50. X to the 6th, y to the -2, all over 10, x, y. So same kind of process here, except can 50 be evenly divided by 10? Absolutely. So again, the numbers stay together. 50 divided by 10 leaves me with what factor, Masha? 5. So I have 5. The x's also stay together. So what's the new exponent here?
So 5.
5. It's 5. 6 minus the invisible 1, okay, is 5. So we have x to the 5th. And then here I have to do a little bit of legwork with the y's because this exponent is negative. I don't have to move it right away. I can still do subtraction first. So I'm just going to expand this out. I'm going to show you what's going to happen. So we have -2 minus 1, which leaves me with 5x to the 5th, and y with a final exponent of -3. Because -2 minus 1 is -3. What do I now need to do with y because it still has a negative exponent? Liam? Put it on the bottom. So this part needs to move to the bottom. So therefore my final answer is 5x to the 5th over y cubed. So this gets moved to the bottom. Everyone good with that? Anyone else have any other topics they would like me to model? Can be from any unit. Morgan? That's okay.
Do you mind modeling like a story problem for an equation?
Yeah, absolutely. Okay, so there are two types of word problems that you're going to have to do for equations. Let me just find one. So there are the linear equations, which we did yesterday. So I'm going to let that kind of be for linear equations, and then I'm going to give an example of a word problem for a normal one-step equation.
Okay.
This one's pretty short. So this is going to be for Unit 5. This is equation word problem. And I'm going to write it down. So Daniel bought where did he buy? Daniel bought coffees. He bought how many coffees? I mean, 1, 2, 3, 4, 5. There's 5 people in. Bought 5 coffees for a total of $20. How much did each coffee cost? So again, I do not want you to write a number sentence, all right? A number sentence has, for example, 5, let's do 20 divided by 5 equals the missing money amount, okay? This is a number sentence because the variable is already by itself. This is a no-no, okay? Do not write it like that. Something has to be happening to x in order to solve for the missing money amount, okay? So we have some keywords in here, right? Keywords like total and each. Okay, so those are big words. Not actually big words, but big hints, okay? So because we have a total of $20, that's typically the number you're going to put by itself. So $20 is alone on one side of the equation. What's going to happen between x, which is going to represent the money spent on each coffee, and the number of coffees we bought? What's going to happen between those two numbers to get our grand total? Masha?
You have to, gonna have to divide.
No, I don't want to divide them. Liam?
Five.
I'm going to want to multiply them, okay? Based on how much each coffee costs and then how many coffees I bought, it's going to dictate that $20 being the answer, okay? So I have 5 coffees times X. So X represents, again, each coffee's cost. So I now have this, I'm going to shorten this. So 20 equals 5x. That's the same thing, okay? How do I get 20 alone? No, how do I get x alone? You might want someone else then. Masha, I want someone else. One of the 3 over there. What? So it's a one-step equation. How do I get x alone? Hey, Gavin. Morgan, what do you think?
You divide by 5.
Divide by 5 on both sides. Okay, so on the right side, 5 divided by 5 equals 1 whole. So now I get x equals $4. So that should be your answer. I'm just recording the class for Jayla. So you can still take a seat if you want, or you can sit in Jayla's spot because she's not coming today. You can stand, as long as you can take out your notebook too. Okay?
Put to write something in it.
Yeah, so I've just been having everyone kind of ask questions about things they want more examples on. So for this type of word problem, I will only ask you to write a one-step equation. Okay? Sound good? All right. Anything else that anyone has questions on that I can model for you? Could be anything. Christine, I'm just waiting because I see you kind of looking, so I'm just going to give you a couple of times. You're not the only one, so. If not, I do have a couple problems that I think would be beneficial for you guys to see again. Kevin, you can use that stool as a desk for your notebook if you want.
I'm good.
Anything? No? Okay. Alright, so I'm going to flip to a new page. If you still have room or you need to go on a new page, do that. Go ahead. It's fine with me. I'm going to review one more thing from Unit 5. So then this is Unit 5. And I'm just going to review fractional coefficients with you, because there will be one problem on the test like this. Okay? So this is always going to be equations for us. Would someone mind providing me with a fraction, please? Masha?
25/4.
Can someone give me a number smaller than 10? Liam?
9.
9 equals, and then can someone give me a number smaller than 20? Gavin?
-1.
-1. Okay? So there's our equation. I did make this a two-step equation, right? But you'll notice that, again, 25/4, this is the coefficient, right? And 25 is not evenly divisible by 4. So that's why this is a good one to work with. All right, so before I kind of deal with my coefficient, right, because I always have to do the opposite of the order of operations. So if the order of operations is GEMDAS, again, I'm doing the opposite, so it's kind of like sad meat, okay? You're doing subtraction and addition first, then moving on to multiplication and division to get x alone. So is there anything that I could add or subtract to start getting x closer to being alone? Nick?
Subtract 9.
Great. So I'm going to subtract 9 from both sides. Positive 9 minus 9 leaves me with 0, so I'm just going to cross that out. Negative 1 minus 9 gives me a new total of,
Negative 10.
good, negative 10. And what's left on the left side?
25 over 4x.
So now we have a one-step equation left, because the only thing that we have is 25 divided by 4 being multiplied to x. Right? So I'm just going to turn back and I'm going to reference the notes that we used on fractional coefficients, which is unit 5. Alright, so that's for me is on page 4. So it says, method, use reciprocals. A reciprocal is a flipped fraction. So if I have 1/2, if I multiply it by 2 over 1, it's going to clear that fraction. So we did an example down here. We had 2/3 x equals 12. And you can see that I multiplied by that fractional coefficient's reciprocal. So that's what I'm going to do over our practice. Okay. So what is the reciprocal of 25/4? Masha?
4 over 25.
4 over 25. So I'm going to multiply by 4 over 25. And what I do to one side, I have to do to the other. So on the left side, these are going to create 1, right? Because 4 times 25 equals 100. And then I have 25 times 4 on the bottom is 100 over 100, which simplifies to 1. Okay? So I'm not really going to show this work. I'm just going to know that these two fractions are going to cancel out. And all I'm left with is x. Over here now, I have to multiply 4/25 by negative 10. How do I turn negative 10 into a fraction that equals negative 10? Christina? Put a 1 under it. Okay, so I have negative 10 over 1 times 4 over 25. So now this equals negative 40 over 25. And it'll be your choice if you want to simplify the fraction or if you want to write it as a decimal. As a decimal, we have negative 40 divided by 25, which is equal to negative 1.6. Or you're welcome to just simplify that fraction. So negative 40. Be the same thing as negative 8 over 5. Because both 40 and 25 are divisible by 5. So if I take negative 40 and I divide it by 5, 25 divided by 5, I get negative 8 over 5. So I will accept either the decimal or the simplified fraction. Okay? There will only be one of these questions on your final. How you guys doing? You doing okay? Alright. There's one more section I would like to cover today. What time is it? It is... Ooh. Okay. So, actually, let me just take a look in your final exam review, because there might already be one in here. So, if you look at your final exam review packet, I'm looking at numbers 28 and 29. So there will be a problem similar to 29, but that has an x right here instead of a number. So all you'll be doing is combining like terms and adding f plus g of x. And you'll also see, so here's f plus g of x, so you'll see that, which you have an example in your notes of. And you'll also see f minus g of x. Right, which I will review tomorrow with you. Okay? So Morgan, you'll get this. I will report to class just the same.
Okay.
Alright? So if you guys would please fill out the back side of your daily grading sheets.
Can I just look on
think that's where I'm going to post the video. I might have to upload it to YouTube first, but there will be a video on Classroom.
Okay.
Yeah, it's Gossi on YouTube.
Yeah, I think it's a YouTube account.
Oh, really?
Yeah.
You like
Thanks,
Gossi?
I forget what it is.